Welcome to topic 3 of the ethical hacking course. And this topic is about protecting computer systems and data and cyber resilience. So, cyber attacks are always on the increase. And as it says here, it's becoming increasingly important for individuals and businesses to evaluate their own cyber resilience. Now, this is not the same as preventing a cyber attack. Cyber resilience assumes that the individual or organization will suffer a security breach, and it is about preparing for that eventuality. So, cyber resilience is about how well and how quickly an organization could recover from a successful cyber attack. So, how quickly can you bounce back? So a small business that has many of its important files on one computer, one server in an office, that doesn't have an adequate backup strategy would have a very low level of cyber resilience. And there are a number of ways to improve cyber resilience, some of which are covered here. So firstly, when we look at a cyber attack, we can consider that cyber attack to, we can consider 3 different aspects of that attack, and those are called the CIA triangle. And in the CIA triangle, we have confidentiality, integrity, and availability. So, for example, if data is compromised, if the confidentiality of data is compromised, what would be the effects of that? So, for example, if your company's finances were exposed to a competitor, that would be a confidentiality issue. Integrity, if the integrity of data has been compromised, that could mean that the data has been altered or changed. Okay, so it can't be trusted anymore. And the availability, probably slightly more obvious, if availability of data has been affected, this would mean that users might not have access to data. Okay, so this is a type of breach for a ransomware attack. Ransomware would be an attack on availability. Now, in reality, many cyber attacks will combine these 3 aspects. So it's essential for companies to prepare for such a scenario. Now, what are some ways that we could prepare for a scenario? One of those is called a tabletop exercise. Now, a tabletop exercise is a planned exercise where employees of an organization work through a hypothetical real-world scenario. Okay, the company would simulate a security breach and then rehearse how they're going to react to such an incident. So tabletop exercises allow organizations to evaluate the tools that they have in place and the procedures that they have in place. Essentially, as it says here, it's a drill similar to a fire drill, which should take place regularly. And obviously, you can monitor how long something was going to take. Now, they're called tabletop exercises because normally you'll sit around a table and discuss what you would do if something happened. So some things to think about are, let's say you take regular backups of data and you're going to do a tabletop exercise to see what would happen if some of your important data was deleted. In the tabletop exercise, part of it would be figuring out what the procedure would be and what the process would be and in what order you would do things to recover that data from the backup. So that's a tabletop exercise. It's a scenario exercise. Now, firewalls. Every computer system or network should have a firewall. The firewall acts like a filter. Firewalls can be configured to permit or deny packets, so to block or accept packets. And users can restrict access that specific programs or services have to the internet. So firewalls do not guarantee safety from a cyber attack, but they do increase the cyber resilience, or decrease the likelihood of an attack. So firewalls can block IP addresses, firewalls can block whole subnets, firewalls can block specific type of files, and they can also block websites or keywords. So all of these things can be configured in a firewall. Access control. Now, access control could be thought of as permissions. So who has access to what data and what type of access should they have? Now, typically a network administrator is in charge of setting up and maintaining this. And a central file server could store files, and each file could have a specific set of permissions on it. So if an individual has only read-only access to a file or folder, it means they can only see it, but they can't change the file or delete it. So often the method used here is called the principle of least privilege. So whatever's the least amount of privilege you can have to do your job is the amount of privilege you should have. You shouldn't have privileges to do anything beyond what you need just to do your job. So two-factor authentication, okay? So two-factor authentication, this is becoming more and more common. This is when you put a password in and then maybe a code gets texted to you and you put in. Two-factor, sometimes multi-factor, it just means there's more than just a password or more than just a PIN code, okay? There's more than one factor of authentication. And we have some examples here. It requires you, it's saying here, it requires you to know two things. So, for example, a user needs to have their bank card and know the PIN. Now, if either of those elements are missing, then you can't take cash out. The same can be applied when you log into a Google account. Normally, you get a pop-up on your phone to say whether or not you're allowed to do this. So that's two-factor authentication. Biometrics. Biometrics is the name given to any type of authentication that uses a biological characteristic. So we have things like retina scanning, fingerprint scanning, we've got voice recognition. So these are quite common to use, and it's going to go through each one of these. So a retina scanner scans someone's eye. Face recognition scans a face. A voice print scans a voice. And obviously, probably the most common one we know about is a fingerprint. A fingerprint scanner would scan a fingerprint. Now, these examples just highlight some common features of security versus convenience. But think about, there is a bit of a balance between security and convenience. So it's saying here, security systems have always tried to manage the trade-off between security and convenience. Biometrics brings security and convenience closer together and is likely to become more common. So the example it gives for inconvenience is if you placed 5 locks on your front door. If you had 5 locks on the door, it probably would make your house slightly more secure, but it would be very, very annoying every time you had to unlock all 5 of them. So here's an exercise about biometrics where we would make use of physical attributes. And if we were doing this in a class, we could do this exercise and work in pairs. But obviously, because we're doing this course online, it doesn't really make sense. We can't sit and talk to each other in the room. Software patching. So when new software is released, it's never perfect. Software development is a process. It's not a single one-time action. There are always bugs or problems with software, and that's why it's important to update and patch software, okay? And we have bug fix updates, upgrades, and patches. Modern systems usually have the option to allow you to turn on automatic updates, Okay, when a flaw or a vulnerability in a system is discovered, usually software developers will release some sort of a fix to resolve this. So we also have backup strategies. Now, a huge volume of data is shared across networks on a daily basis, and data backup was traditionally viewed as a means of keeping a second copy of data in the event of hardware malfunction. If a server went down, users could access the backup once it was made available. Now, sometimes this would happen very quickly, but other times it could take a day or two for a backup to be accessible to users. Now, there are different types of backups, and the types of backups that this course wants you to know about are these three. So the easiest one is a full backup, okay? And this just means you complete you take a complete second copy of everything you've got. Then the two that are a little bit more abstract, shall we say, is a differential backup. So a differential backup's quicker because only the data that changed since the last full backup is backed up. So what data is different? You can think of different. What's changed? What's different since the last full backup? That's why it's a differential backup. An incremental backup is more efficient and it will only save changes since the last backup of any kind, regardless of whether the last backup was a full backup or a differential backup or an incremental backup. So there are no specific rules on how we should back up, but it's common to do full backups once a week with differential or incremental backups happening on a much more frequent basis. Okay, so intrusion detection. Cyber attacks can be difficult to detect. An intrusion detection system is a system set up with the purpose of identifying the presence of a cyber attack before it can do serious damage. Now, a number of techniques can feature as part of an intrusion detection system, and these include the following. So we have monitoring network traffic. So a network IDS can be set up to monitor network traffic, and if traffic suddenly increases, this could trigger an alert. A honeypot is the name that's given to a fake set of sensitive data. It's deliberately stored in a discrete area of a network. So a honeypot can be used to try and attract cyber criminals, and these are used to decoy and to deflect attacks. And what we can do with a honeypot is we can see where attacks are coming from, and then we can use that information to patch our real system. So a honeypot is a sort of a decoy to try and lead attackers in, try and lure them in. And once data has been accessed, we can see how they accessed it and what they accessed, and then we can put measures in place to prevent that happening to our real systems. So the final and probably the most important part of cyber resilience is actually staff training. So how do we prevent members of staff? So if we think the weakest element within a system is the human element, because humans can make mistakes. People can leave passwords on pieces of paper. People can give away information on the phone. People can leave doors unlocked. So providing staff training on a regular basis can significantly increase cyber resilience and can also decrease the likelihood of an attack. So many organizations are required by law to ensure that their staff have completed some sort of mandatory course, but this could also be supplemented by some user awareness training, some practice of awareness of common scams, so that staff are less likely to fall victim to an attack and are more likely to be able to be in a position to do something about it if they are attacked. Now, let's have a little look at a risk impact matrix cyber. See if we can find some sort of a risk impact matrix. So let me jump this over here. Let's do risk. Let's have a wee look. So let's go for this one. Seems fairly simple. So let's open image in new tab and let's have a look at this. Oh, it's not going to be a great resolution, obviously, but let me just put it to an acceptable enough. Let's see if we can find one that isn't a horrible resolution. Let's go. This seems fairly straightforward. Let's try. No, we don't want to save image. We want to open in a new tab. Let's try this one. I don't want to put up something that's all okay. That's equally as bad. Let's go for this one. What is it with people who do risk? You know, what's the risk of a risk matrix being very low resolution? It's very high. So, hopefully, although this is blurry, I'll explain what the concept is. So, if we are going to fall victim to a cyber attack, how likely is that? What is the probability of it? Is it unlikely, like it's never going to happen? Is it likely? Is there a likelihood of it happening? Or is it very likely? Is it very likely that we're going to be a victim of a cyber attack? Okay. Now, if that attack takes place, what will be the impact of that attack? For example, if someone leaves a door unlocked to a printer cupboard, that might be quite low risk, but it might be also very likely to happen. So is that acceptable? It's in a yellow category. So according to this diagram, the worst thing that can happen, okay, is for something to be very high impact and also very likely to happen. And that would take us to this area here, an unacceptable extreme risk. Okay, so when we think about our resilience, we obviously want to prevent this. This would be the worst thing that could possibly happen. But as the likelihood decreases and the impact decreases, the risk also decreases all the way down here. So we need to be aware of how likely something is to happen, but also what's going to be the impact of that happening. Okay, and there is a formula for this called risk equals threat times vulnerability. Let me just grab an image of this. So someone must have written it down. Here we go. So risk equals TVC would be the formula. Again, another terrible resolution graphic, but the formula is risk is equal to threat times vulnerability times cost. So that's a formula for working that out. Okay, folks, right. Let's have a wee look through these questions then. What happened to Amir today? Did he disappear? Let's see if he's in the participants list. He's in the participants list. Oh, okay. Okay, so let's have a look then. I'll zoom this in so we can see better. 100%. Right. So, question number 1. What is cyber resilience? Cyber resilience is the ability to prepare for, respond to, and recover from cyber attacks. Very good. That is fine, absolutely fine. Let's go green with that one. Right. In the CIA triangle, what is C? C is confidentiality. It's relevant to an attacker because the attacker is able to extract data and create a copy of it. Okay, why is it relevant to an attack? Yeah, so we could also say this could compromise the secrecy. This could compromise internal confidential documents. Okay. But otherwise, this is a good answer. Okay, number 3. Cyber attacks are often analyzed in terms of their effect on CIA. What does the I stand for? So I stands for integrity. Okay. Now, it says here, it's important for the data offered to be correct and authentic. Okay, hang on, I'm just trying to put this back to 90. There we go. After a data integrity breach, data's integrity can be altered to reflect something intended. Very good. Although, can I ask why you wrote this in Book Antiqua font as opposed to Calibri or Arial? I think we're in this one. There. That's better. We're not right. That's a pretty good answer. We'll go okay with that. A stands for availability. Keep networks and systems running, being available to people. Okay. So the would be a direct attack at the system. Something like that. But otherwise, very good answer. So let's go green with that. Right. What's a tabletop exercise and how is it beneficial? The company is an assessment. Yes. Yeah, pretty much. Let's just change this to it is a rehearsal of a scenario. So a tabletop exercise is just when you sit around a table and you have a practice of what would happen if you were a victim of a cyber attack. Okay. All right, I see. You've got some kind of strange half question. Okay, tabletop session meeting. All right, that's my mistake. Let's just say we'll take that out of there, and let's say we'll put that into there, put a question mark, and we will get rid of this. Delete row. Okay. Explain why it is important that software patches are installed. Right, to reduce exposure. Very good. That's fine. Absolutely fine. It is important for organizations to ensure that they have a robust backup system. What is meant by a full backup? Entire storage device. Perfect. Right. It is important for organizations to ensure that a robust, what is it? It's the last backup. Perfect. Okay. Don't know what happened to Emil today. Let's go to this one. Right. A company takes thousands of online orders per day, more than once a week. Hourly. Yes. Yes, hourly is good. Let's do... Okay. Intrusion detection. Honeypot is a fake computer. Yes. Perfect. It could also be like a honeypot could be like a fake server or something, or a fake router, or a fake. You could even put fake CSV files inside a honeypot server. Right. Staff training. Describe data security. Yes, this looks good. Okay. Two-factor authentication is available on many online services. How? Two-factor. Difficult. Yeah, that's good. Two forms of identification. Fingerprint. Ethnic targeting becomes a possibility with this technology. Agencies can store fingerprints indefinitely. There are data protection issues to consider with DNA fingerprinting. What are the flaws with fingerprinting? Yeah, okay. Facial recognition can be spoofed and hacked. How can facial recognition be spoofed? Cutting someone's head off. Holding it up to the camera. Okay, interesting. Right. So what happened to Amir then? What happened to his question? You're not doing it, not taking part today. Okay. A company that takes online orders, explain why this backup strategy is inefficient. Okay. Could be improved. It's inefficient. Okay, hold on. I'll just change this to me. The backup could be improved by making the backups more frequent than once a week. I'd say that's, let's just fix that. I'd say that's a fair answer. Let's just click there, turn that green, turn that green. All right. Oh, no, don't turn that one green. We want that one to be that color. There. Oh, no, the text's red now. This is no good. Right. Okay, so there we go. So I'll make these available on the Moodle. These are good revision questions for any tests that we have coming up in the future. So let me just download those. Save as, download a copy. Ethical hacking topic 3, save. Okay, so those are the questions. We're going to look at the lab now. So let me just jump over to the Moodle page. So let's just go back. I should have just clicked up here. Okay, so just wait for this to load. Right, so this week, what we've just covered, all right, was topic 3 there. Let me just make that available to you. So topic 3 was cyber resilience, and over the holidays there, and in the last week, we were looking at lab 3, which is the nmap lab. So in lab 3, hopefully, everyone was able to import the OVA file and run some nmap scans on it. And I saw some quite good engagement on the chat, and I think George Mason enjoys helping you there as well. So, oh, there's a little typo there that I should probably fix. What is that? That is a typo on 2.5. Hold on, let me go and fix that. Well spotted. If you spot any typos, let me know. Funny, because this looks different from what I have here. Let's do 2.5, 2.6, and let's make this 2.7. I'll tell you what's wrong with these as well. They need to go into a monospaced font. Okay, that's better. That's a bit better. I'll download that and add it to the Moodle page. I'm about to add the questions to the Moodle page as well. Okay, so what I'm going to do is just in a minute, I'm going to review everyone's upload for that. Now, I know some people have had some problems and you've messaged me and let me know. So that's okay. That's no worries. What we're going to do now, though, is I'm going to show you what's involved in Lab 4. Okay, so let me just show the topic for Lab 4. And let's just leave the theory topic away just now. And let's have a look. So what we're doing in Lab 4 is we're going to look at Metasploitable. Okay, now Metasploitable is a type of machine that's very exploitable. Okay, it has a lot of vulnerabilities that we can, so it's easy to hack into. It's an example of a very hackable machine. Metasploit is a framework for hacking, and a Metasploitable machine is a very exploitable machine. So what we're going to do is we're going to click this link here. Now, you don't need to do this just now because this is quite a big file, okay? We download the Metasploitable machine, and then once we get logged into it, we're going to make a file called target.txt. Then we're going to edit target.txt and add the words lots of secret stuff to the file, okay? Then in our Kali machine, we are going to find the IP address of the target and scan it with nmap, okay? Then we are going to try a different piece of software called Legion, which is an nmap graphical front end, and we'll just be doing a similar type of scan with Legion as well, okay? Then we are going to access the MSF console, and we're going to search for a vulnerability called the Unreal RCD vulnerability. Then we're going to tell Metasploit to use this exploit, okay? We're going to set some options in the exploit, and then we are going to exploit the machine and get in, and we should be able to visualize the target.txt file that we created way back in step 1, and we're going to create a file called hack.txt to show that the machine's been hacked, and then we'll go all the way back to our Metasploitable machine, and we should just be able to type ls, and the hacked.txt file should be here, and that is lab 4. So what I'm going to do is I'm going to set the upload date for this one to be just before our class next week, where we'll go on to the next topic. So today is the 15th. So the upload for this will close on the 22nd. So let's do, don't need to touch the year or the time. Let's just change this to the 22nd of February, and let's set the time to right before our class. Now, if you were very silly, you would leave it until next week. But if you were very sensible, you would use the class time tomorrow to start doing the lab, and any problems that you had, you could ask in the chat, and we'd be able to advise you. You can message me, or you can post into the chat, and someone else might be able to answer your question if it's not. So that's available on there, and the upload for the ePortfolio evidence is available here as well. Okay, so here's my score. I only got 14 out of 16 on my own quiz. So I actually set myself a quiz and got 2 questions wrong on it. So the 2 people who got 14, I'm going to guess you got the same problem questions as I did. So anyway, that was silly of me. But mind you, I did it in 2 minutes and 38 seconds, but I only got 88%. So, okay, so question 1, right? I'll zoom this in so it's easier to see. Okay, so what is the MAC address of the Wi-Fi adapter? So what we're looking for here is the adapter with the W in it. That's the clue that it's the Wi-Fi. Obviously, Ethernet, Loopback, VMnet, VMnet, VMnet. So by elimination, we can see that the W1 is the Wi-Fi adapter. Now, what is the MAC address? It's this thing here. All right, so ends in 9E. So there's that answer there. Okay. Question 2. What is the subnet mask of virtual network 8? So let's go to VMnet 8. Oh, hold on. Down the bottom here, the subnet mask on VMnet 8 is a really easy one. It's just 255.255.255.0. I got this wrong though. It's a bit of a trick question, to be honest. 24, technically, that's the prefix length, right? There's 24 bits in the subnet mask. but technically that's not the subnet mask. Technically the subnet mask is 255.255.255.0. I even tricked myself with that question. Question 3 is the same. The subnet mask is 255.255.0 and I put 24. So, right. Question 4. What is the MAC address of the loopback adapter? Okay, so we're going to go to loopback. We're going to go to the MAC address and you'll see that it's all the zeros. Okay. Question 5. What is the queue length of the loopback adapter? So this, we're just trying to read the loopback adapters here and look at this bit. QLen is queue length. Okay. 1,000 there. All right. Question 6. Consider the following. What is the queue length? So again, we're just looking at virtual network 15. QLen is 1,000. There we go. Question 7. What is the MAC address of the Ethernet adapter? So this time we're wanting to go to this adapter, and the MAC address is here, ends in CB. So it's this one here. Okay. Question 8. What is the network address of VMnet 8? So all the way down to VMnet 8, and we don't want an IP address, we want the network address. And guess what? The network address is this, okay, but with a 0 here. All right, so that's why it's 192, wait, VMnet 8, sorry, this one, VMnet 8, that with a 0 there. So that's why it's 172.16.1890, and the same for the network address of virtual network 1. So virtual network 1, it's 45.0. All right, 45.0. What is the host address of the virtual network 1 adapter? So the host address is just another way of saying what's the IP address of the virtual net. Now, so there's ENO1, here's VMnet1, and here is the host address. All right, 192.168.45.1. So there we go. What is the host address of the virtual network 8 adapter? So same thing, VMnet 8. What's the address there? The address is 172.168.1.1. Okay, and what is the, okay, true or false questions now. These are a bit trickier, okay, but you've got a 50-50 on the question. So, okay, the value of the last hex character in the Ethernet MAC address is F. So, to do this, we've got to reverse, right, what we're looking for. First of all, Ethernet. Second of all, MAC address. Third of all, last hex character. We know that MAC addresses are in hex, okay? So the last character is this one, B. Okay, so it's false. It's not F, it's B. Okay, so false. Next one is the value of the last hex character in the virtual network MAC address of VMnet 8. So let's go to VMnet 8. Close that down, scroll down. VMnet 8. The last character is an 8, and it is. You should be able to spot it. Here's VMnet 8, here's the MAC address, here's the last character, and it's an 8. All right, so that's true, that one. And question 14, the value of the third hex character in the virtual network adapter 1 MAC address in binary. So we're going to have to do a lot of reverse engineering here. So let's find the virtual network adapter 1 MAC address. So let's scroll to VMnet 1 MAC addresses, this thing here. Okay. Now, the third hex character is 005. So it's 5. But we need to convert that to binary. So you need to remember my old trick of 8, 4, 2, 1. Okay, hopefully you remember that from Cisco Network Essentials. So if we add, okay, 0, 1, 0, 1. If we add 4 and 1, that gives us 5. Okay, and that is why that one is true. So hopefully that jogs your memory on that one. Last question, I think. The value of the second hex character in VMnet1 IPv6 address. So let's jump to VMnet1 IPv6 address here, and we're looking for the second hex character, which is E. So remember the trick, 8421. Okay, and if we remember that F is 15, so E must be 14. So to make 14 out of these numbers, we have 18 plus 14 is 12, plus a 2 is 14, plus a 0. So this is true. 1110 gives us 14. Okay, and the last one, the second hex character, it's going to be a 0. If it's all zeros, it's going to be a 0. So the second hex character in the VMnet8 adapter IPv, right, all the way down to the VMnet8 adapter. So let's go to here. The second, what was it we're looking for? The second hex character. So the second character in the IPv6 address is in E. So it can't be 0000. So that one's false. Okay. So that's hopefully cleared up some stuff for everyone today. Well done, everyone, for doing this. Okay. Some really good results. Some people did just as well as me. So that's a good indication that things are going well. Okay. So that's the end of the class today.